Okay, here are the answers to the DSAT number 3 worksheet that you guys did last night for your homework. So, the first two are proofs. I know, your favorite. It says there was an error in here, and I want you guys to fix it. I want you to change the angles to angle ABD is congruent to angle BDC. That'll help you get this correct. So it says, it tells you that we have this quadrilateral ABCD, and it says AD is parallel to BC. That's given to us. So when we have parallel lines, we're always going to think about alternate interior angles. And if you look at ABD is congruent to BDC, those are indeed alternate interior angles. And then the next step says AB is congruent to DC. That's in the given, so your answer is given. So we know these two sides are congruent to each other. And then the last thing, it says BD is congruent to BD. That is the same line, so that's called reflexive plot. And then why are these two triangles congruent? There are 5 reasons that we learned in chapter 4 to prove triangles are congruent. It's either SSS, SAS, ASA, AAS, or HL. And the reason why these two triangles are congruent, we have a side, we have an angle, and we have another side, so SAS is going to be the correct answer. If you used the angles I gave you originally, it would have spelled a bad word, and that's why I had to change it. Okay, number 3, name all similar triangles. This one's going to be kind of pretty. So the first 2 that you guys can see are pretty straightforward. This is going to be similar to this one, and to check it, remember you look for the sides to see if they're proportional. So 8, oops, changed it. So 8 looks like side 12 in this triangle, and 12 looks like side 18. You can put this, oh, sorry, we're not using calculators, but if you notice, they both reduce down to be the same thing. Let's see, if you divide both of these by 4, you get 2/3, and if you divide both of these by 6, you get 2/3, so the sides are proportional. So the first one you could say is FIJ will be similar to GIH. On the exam, it's going to be multiple choice, so this could be an answer. Something else in this picture, let's see, so we said the easy ones. Oh, there's one more easy one. That would be that this top triangle is going to be actually congruent. So if it's congruent, it's similar to the bottom triangle. We have 13.6, 13.6, 8, 8, 12, 12. So these are actually congruent. So you could say FIG is similar to JIH. So those are the easy ones. Now these ones are the harder ones. The last 2 are kind of harder to see. But if you look, let's see. This triangle is going to be similar to this triangle because you have a 13.6 and a 13.6, a 12 and 12, they both share this side, and then 8 and 12 and 8 and 12. So they're actually congruent triangles. So you could say GFJ is similar to HJF. HJF. Okay, so those are a little bit harder to see. There's one more set of similar, actually congruent triangles. And let's see if anybody got this one. This fat one right here. Let's see, we have a side 13.6 and 18. 13.6 and 18. And then if you notice 8 and 12, 8 and 12. So FGH is going to be similar to this fat one right here. So that would be, let's see, FGH, JHG, JHG. And again, you can look at the sides, 13.6 and 13.6. They both share an 18, and if you look at these, we have 8 and 12 and 8 and 12. So they're similar and congruent triangles. Okay, moving on to number 2 and 4 and 5. Okay, number 2, another proof, sweet. It says XZ is a median of WY, and median means that it cuts it in half. So Z is going to be the midpoint, and it tells you that XZ is actually also perpendicular. We want to prove why a part of a triangle is similar to another part of a different triangle. So given, we're going to say XZ is a median, And the proof on your test isn't going to be this hard. I just made it more challenging for you guys because you're that awesome. I said Z is the midpoint of WY. That's what median means. So if Z is the midpoint of this line, then that means that these two sides have to be congruent to each other, because that's what the word midpoint means. So step 3, you're going to put WZ is congruent to YZ or ZY. It doesn't really matter. Okay, and then step 4, it says XZ is perpendicular to WY. That's in the given, so you're going to write given. And then for number 5, this is going to be a right angle, and this is going to be a right angle, because that's what the word perpendicular means. And since they're right angles, they have to be congruent to each other. That's what step 6 says. Number 7 says reflexive plot XZ is going to be congruent to itself. And some of you guys are thinking right about now, why are we going through all this mess again? We just wanted to prove that angle W is congruent to angle Y. Well, in order to prove that parts are congruent to each other, you first have to prove that the triangles are congruent. And remember, there are 5 ways to prove triangles are congruent: SSS, SAS, ASA, AS, or HL. So looking at this, some of you are going to think it's HL, but it's actually SAS, because we have a side, an angle, and a side. HL is when we know that the hypotenuse are congruent. So you can say, there are different ways you can write this, but I'm going to say that WZX is congruent to YZX. And the last statement, the reason why we can now prove that parts are congruent is by CP/CTC. So the last thing should be CP/CTC. Corresponding parts of congruent triangles are congruent. Got it? It might be written out on the test. It might not say CP/CTC, but you know that it stands for corresponding parts of congruent triangles are congruent. Okay, number 4, last typo. My bad. We don't care about TS. I wanted you to know that VS equals 6. Okay, so my first hint to you guys is to draw a picture. So I drew my picture like this, RST. You could draw it a different way if you wanted to. It would still be fine. And it says that TV is the perpendicular bisector of RS at point V. So perpendicular means it meets at right angles, and it also means that these two pieces have to be congruent since it's a bisector. Okay, so now I tell you RT equals 10, TV equals 8, and VS should equal 6. So why are these triangles going to be congruent? Remember, there's only 5 ways. If this part is 6, that means that this part also has to be 6, because it's a perpendicular bisector. So now we have 2 congruent sides, we have 1 congruent angle, and we have another congruent side. So it's going to be congruent by side, angle, side. Okay, and let's see, number 5. Given right triangle DEF with right angle DFE, and CF is an altitude, that just means it hits at a right angle. Which theorem could be used that they're similar? And there's only 3 ways to prove triangles are similar. Those are angle, angle, SSS, and SAS. So one of those has to be your reason. And this one, the easiest thing I can tell you guys to do is to take an angle, any angle. I'm going to pick D because I want to, and give it an angle measure. Any angle measure, doesn't matter. I'm going to go ahead and pick 10 degrees. I'm going to say that looks like 10 degrees to me. All right, this is a right angle. This one has to be a right angle. Now, I want you to finish this triangle right here. Well, if that's 10 and that's 90, that means that this other angle right here has to be 80 degrees, because all the angles add up to be 180. Well, this is a right angle right here. So if this is 80 degrees, then that means this remainder has to also be 10 degrees. And now if we look at this smaller triangle, we're going to fill in this missing angle, 10 degrees, 90 degrees. That means this one has to be 80 degrees. So why are all these triangles going to be similar to each other? We don't know anything about the side lengths. We don't know anything. We do know, though, that they have congruent angles, 10 and 10, 80, 80, 90, 90. So the reason your answer is angle, angle similarity. Okay. Number 6, again, we're not using calculators, so some of this is going to be a little hard for you guys, but I want you to remember that if c squared is bigger than a squared plus b squared, that means it has to be obtuse triangle. If it's less, it's acute, and if it's exactly equal, then it's a right triangle. So what you had to do for this one, it asks you which one's a right triangle. You just had to do 3 squared plus 4 squared equals 6 squared, and figured out that that doesn't work for all these problems. And remember, the largest one is always going to be your C. So for this one, it would be 15 squared plus 34 squared. Does it equal 39 squared, and it doesn't. And if you did it for D, it doesn't either. So C is the only one where it did work, and 26 has to be your C, your hypotenuse. So if you did that, it would have come out to be, I think it was 676 equals 676. So it's the right triangle. Okay. Number 10. In right triangle EFG, cosine E equals 3/5. What is sine E going to be? So draw a picture. And we have E, F, G. And I'll say that F is the right angle. Okay, so cosine E, in respect to this angle, cosine, you know, is comparing the adjacent over hypotenuse, because our SOHCAHTOA is our little way to remember. Okay, so sine E, or cosine E is adjacent over hypotenuse. If this is a right triangle, we can figure out what side this is going to be by Pythagorean's theorem. So the first thing you could do is figure out what the opposite side has to be by doing Pythagorean's theorem. Some of you already know, since this is a basic Pythagorean triple, that this side has to be 4. Now that you know what this opposite side is, the second thing you can do is compare. Sine of angle E is the opposite over hypotenuse, so the opposite side is 4, and the hypotenuse is 5. So your answer is just 4/5. You're done. All right, so those are some of the answers for the worksheet.